Hey, good morning, Lorenzo. How are y'all doing? Um, Great. If y'all talk to Alex, tell him I hope that he's recovering well from his surgery. Excuse me. All right, um, opportunity to address questions over assignment 9, slope, equations of lines. Um, and we will conclude class today with a quiz over week 5 quiz assignment 8. So, what can we look at in terms of assignment 9? Anything?
Can we go over number 30?
Number 30, assignment 9. All right, so we have a review problem. Um, Roughly speaking, here is what we're looking at. So we have a series of questions. Number 1, A, is it a function? Yes or no? You tell me. Why?
It passes the vertical line test.
Vertical line test, check. Good. B, the domain. What is the domain? The values of x, right? What values of x are on this graph? Or are represented on this graph?
36.
No. The values of x, the domain, is all the x's that are on this graph. So, think of yourself as a scanner. As you're scanning this graph, and by the way, this graph continues going continues going in the upwards direction. As you scan this graph from left to right, if my pencil is my scanner, if I'm over here and I'm scanning the graph, somewhere way up here, this pencil is going to interact with the graph because the graph keeps going up and up and up. So when I look at this graph, because of the arrows that tell me that the graph continues going upwards and out, the domain is all real numbers from negative infinity to positive infinity. Every single value of x along this axis will have an output value. I pick an x way over here, the output's going to be way up here. I pick a value of x right here, the output's right here. I pick a value of x way over here. Now I have to go way, 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 way up. I have to zoom way, way out. But if I pick an x way out here, at some point, this graph is going to continue going up and it's going to interact with that point. So your domain is all real numbers from negative infinity to positive infinity. Your range is the set of y values. It's what y values are represented on this graph. So our range, again, if I'm going to act like a scanner, if I'm scanning now like this, up and down, if I scan way up here, if I look across this line way up here, yeah, the graph is going to interact with this line. So way up here at positive infinity, my graph is interacting with something way up there at positive infinity. But if I scan down here, way down here at, let's say, negative infinity or negative 10, the graph isn't coming down this far. The graph doesn't come down this far. It only goes down to y equal to, to y equals 0. So our range is from 0 to infinity, bracket around the 0, because we can clearly see that it's touching the x-axis. See, where is it increasing? Well, the graph is increasing here. Now, this has nothing to do with that y value of 36. It has everything to do with the x values. So imagine that you're walking along the x-axis and you're looking at the graph. So way over here, starting at negative 2, you're standing right here at negative 2, and you start walking along the x-axis. You start looking up, and you see that as you're walking in this direction, that the graph continues to go up and up and up. So starting here at negative 2, all the way out here to infinity, the graph is increasing. So again, you're taking a little stroll along the x-axis. And as you're strolling along the x-axis, you're watching and you're observing what the graph is doing. And as soon as you're at negative 2 on the x-axis, you observe that the graph starts going up. And way out here, you start looking up. And yeah, the graph is going to continue going up way out here. As you start to look up, I'm looking up. There's my looking up. I'm seeing that the graph is increasing. The graph is decreasing. Again, you're taking a stroll along the x-axis. And starting way out here at negative infinity, way out here at negative infinity, I'm observing that as I'm looking up at the graph is going down. As I'm strolling along the x-axis, I'm seeing that the graph is going down, and it's going down all the way to the point where I get to negative 2. Does that make sense? About increasing and decreasing? It's all about your scroll along the x-axis. D. We have no max, or I really should put maxima. There is a maximum infinity, but there is no maxima. And we have a minima at the point 0, -2. That's where the point graph transitions from decreasing to increasing. E, is it odd or even? It is neither, because it's not symmetrical about the y-axis. Yeah, it's symmetrical if you spin it around here at y equals -2, it would be symmetrical, but it's not symmetrical about the y-axis. If I were to take the y-axis and spin it like a top, the left-hand side is not going to be the same thing as the right-hand side. We don't have a mirror image. If this pencil line represents my mirror, I don't have a mirror image on the left-hand side and the right-hand side of the y-axis. F, what are the intercepts? Well, there's two types of intercepts. There's x-intercepts and there are y-intercepts. Where does it cross the x-axis and where does it cross the y-axis? So this graph crosses the x-axis at -2, 0. And there's only one y-intercept, and that only y-intercept is right here. That's why they give us that information at 0.36. So does that address your questions over assignment 5 or problem number 30 from assignment 9? Okay. What else can we look at? Excuse me.
22.
20 what?
22.
22. We want the equation of the line that is parallel to 2x minus 5y equal to 6 and passes through the point -1, 4. We want the equation of the line that is parallel to this given equation, and it's passing through this point. So, when we talk about the equation of a line, we're talking about where starting point is typically going to be y minus y sub 1 is equal to m times x minus x sub 1. This is our point slope equation. So, we got a couple of things that we already know. We already know what x sub 1 is. We already know what y sub 1 is. The thing that we don't know is m. That's the one thing that we don't know right now. We don't know what m is. And we're going to find m. We're going to use this equation to find m. To find the m that's going to go right up here. Alright, so let's start off with that equation. 2x minus 5y equal to 6. And let's solve for y. Now, there's a reason that we solve for y, because if we solve for y, we're going to get y is equal to m x plus b. We will then know what the slope is of this line. If I solve this equation for y, I will then know what the slope is for this line. I'm not talking about this line yet, I'm talking about this line. So how do we solve for y? Well, I'll start off by subtracting 2x on both sides. And then we'll divide everything by -5. That gives me y is equal to a positive 2/5 x minus 6/5. Maybe I should have used a different color here rather than orange, because I don't want to confuse the situation here, but what I just found was that m for this line is 2/5. That's the slope for this line. Now, we want the slope of the line that's parallel. So, the parallel slope m parallel, so we'll call this m parallel, is going to be 2/5. Parallel lines have the same slope. So this is the slope that we're going to plug in up here. The slope of this line, since we're talking about parallel lines have the same slope, right? Slopes don't change. This is the end that we plug in up here. Now, if it was perpendicular, which you have a problem on here, like problem number 26, if it was perpendicular, you would do the negative reciprocal of this slope, and you'd plug it in up here. So at this point, we just got to go through and do the work. So we have y minus 4 is equal to our slope of 2/5 times an x minus a -1. And we want to go through and solve that equation for y. So we got y minus 4 is equal to 2/5 times an x plus 1. So we got y minus 4 is equal to 2/5 x plus 2/5. Then we have y is equal to 2/5 x plus 2/5 plus 4. Now what we want to do is we want to combine these two numbers together. So I'm going to think about taking that 4, I'm going to multiply it by 5 over 5. So this gives me y is equal to 2/5 x plus 2/5 plus 20 over 5. And now I can combine these two terms together, so our final answer is y is equal to 2/5 x plus 22 over 5. Hold on. What problem are we looking at? Problem number 22? Alright, I have a problem. What's my problem with problem number 22? I used the wrong point, didn't I? Yeah, I used the wrong point. I wish y'all would have stopped me. Y'all may not have realized that, but I used the wrong point. Sorry about that. Shoot. The point that we want to use, I was looking at problem number 23, is -3/5. Okay, so let's make some adjustments here. So that's going to be a minus 5 right here. Let's make that a little bit bigger. Minus 5, then minus 3. So we have minus 5, that's going to be plus 3. So we have minus 5. Distribute the 2/5 to this, that's going to become a 6/5.
Sir, it's a -5 instead of a +5.
It's a negative 5. Alright, so that makes this positive, positive. Yeah, I was looking at that. That's a positive 5. So that makes this a negative 5 right here, which makes this a so that's 6/5. So that makes this a negative 25 over 5, and that's still 6, which then, here we go, now we got it. Y is equal to 2/5 x, and then 6 minus 25 is a negative 19 over 5. And there's the answer that we want. Alright, sorry about that. So that was a, back up here, that's a negative 5. So y minus a negative 5 is the same thing as y plus 5. There we go. Alright, sorry about that. Got to read the problem correctly. Does that make sense how to approach problem number 22? Okay. What else can we look at? We have a few minutes that we can look at another problem.
I had 26.
26. Alright, so same thought process. We want to plug things into this point slope equation. That equation right there. So the first thing that I'm going to consider doing is I'm going to take a look at this equation. And I'm going to find its slope. So to find the slope, we're going to go through and solve for y. So that gives us a negative 5y is equal to a negative 3x plus 2. Divide everything by negative 5, and we get y is equal to 3/5 x minus 2/5. So this tells me that m is equal to 3/5. Okay? Now that's the slope of this line, but we want the perpendicular slope. So the perpendicular slope to 3/5 is m is going to be equal to, perpendicular means to do a negative flip. The opposite of 3/5, the opposite of 3/5 is a negative 5/3. So this is the slope that we're going to plug in up here. And these are the points that we're going to plug in for our x and y values. So what you're going to do is you're going to go through and solve for y. Y minus 10 is equal to a negative 5/3 times an x minus a negative 6. Go through and solve for y. You get y minus 10 is equal to a negative 5/3 times an x plus 6. Y is equal to a negative 5/3 x. Negative 5 times 6 is negative 30, but divide that by 3. You get a negative 10, and then you're going to add 10 to both sides. Negative 10 and positive 10 cancel out. You get y is equal to negative 5/3 x. Now, this is all we got time for, because we're about to start the quiz for this week. But I'm just going to give you a heads up, because I like to give you a little heads up when it comes to exam questions. This particular type of question is a favorite exam question of mine. This kind of question, where you find the equation of a line perpendicular to another line through some given point, that's one of my favorite types of exam questions that you'll see on exam 2. So, now you know that you can probably expect to see this again. So, with that being said, we're going to put away all of our notes and other papers, and we're going to get ready to take our exam 5, or not exam 5, quiz 5. Week 5 quiz. So if you would put away all other material, and if the facilitator would please distribute the quiz for the week. We will be spending the rest of our time working on that quiz. You'll scan and upload the quiz into Gradescope through Blackboard. The Dropbox is already there in Blackboard for you. So I'm going to mute my mic, but if you have any remaining questions over assignment 9, shoot me an email, and I will get to them before the due date for this week, which is going to be Sunday at midnight. All right, take care, and I'll see y'all on Monday, or I'll hear from you by email.
Your conference is scheduled to end in 2 minutes.
So I have the time set for this to be due at 11 o'clock. So if you're needing to wrap up a question, make sure that you get those wrapped up and submitted by 11 o'clock. Again, if you have any further questions over assignment 9, please feel free to email me, and I'll get to them as soon as I can. And we will pick up next week with assignment 10. What is assignment 10? Assignment 10. Distance, midpoints, and circles. We will spend Monday talking about assignment 10. So, I will see y'all on Monday. Have a wonderful weekend. Bye.
Your conference is now over. Goodbye.